Research is fundamentally about uncertainty. It's very much about taking something that nobody knows the answer to. One end goal for AI research, one could say, is like trying to create boundlessly self-improving AGI. We are not really taught how to deal with uncertainty and how to break down uncertainty. With research is that you don't even know if you're solving the right thing and if the problem definition itself needs to change. I was at IIIT Hyderabad, where at this in the same lab as Akshit. I started doing research around like 4 years ago in machine learning, and yeah, so 3 years I did it at IIIT, where I was doing like my master's and undergrad, and now I started a PhD program in Germany like a year back. And yeah, so mostly this talk will try to like combine some of the principles I've learned about doing research until now. Obviously, like I've only been doing research for a short time. If you look at like any senior researcher, they've been doing research for very long. So this is just like some principles that I'm hoping to incorporate in my own like workflow. It's not necessarily that I've managed to like fully incorporate these principles as well. I think it's some of these are just hard. So I'm very happy to like take more questions at any point. Just feel free to stop me and like ask me questions, because a lot of these are things are subtle and even I don't know how to like fully like incorporate them in my research. So would love to like discuss. Um, so yeah, let's start. So I guess like the first question that needs to be answered to do like such a talk is first for like what is research and how is it like different from any of the other things we've been doing. Like and I think in general there's like a lot of confusion around what research is in the AI space these days, because people like now want models to do research. And I don't know if you guys have been following this. This is like an interesting direction, which is that okay, we have models that are excellent at like finding like literature, summarizing literature across the web now with like the deep research models. They're called like deep research. We also have like models which are capable of solving like graduate level biology, chemistry, physics problems, which like PhD students can't solve, maybe professors can't also solve. And then people say that, oh, we already have like PhD level models, why do we need to do a PhD? And like I think this comes from like a fundamental misconception about like what research really is and what, let's say, a PhD entails. So yeah, so I think the first thing to make clear is that like research is fundamentally about uncertainty. It's not about taking like a scoped out problem and like finding a solution to a scoped out problem that's someone already knew how to solve. It's very much about taking something that nobody knows the answer to. There is like general, like it's not just your own uncertainty. Like you can have uncertainty at a personal level, and like trying to fix that research can help in like trying to bring more clarity there. But also like when you're doing like when you're hoping to write a research paper, what you're trying to do is like reduce uncertainty in the whole community. So yeah, so you can, so basically what would this look like? Well, you could start with like some end goal. So for example, one end goal for AI research, one could say, is like trying to create boundlessly self-improving AGI. Uh, so yeah, uh, I I won't go a lot into like what that term means right now, but some of you might like roughly get what I'm trying to say here. And I guess a critical uncertainty here is that if you want models to really be like self-improving without any like plateau or bound, like for example, humans can like keep adapting to new technology, keep learning new knowledge, new information. Then how do models continue improving without like learning from human data? Because only then can you like self-improve in a way where like maybe humans don't know something, but you can still find the solution to that. And I think this is like a critical uncertainty here, which, for example, most people haven't solved yet. Like hill climbing, normal, like the benchmarks that are popular, that isn't really like like improving without human input necessarily, because like even the benchmark itself is like sort of an input that humans created. You're training on human data, so like once you start training on human data, you're still not like boundless. You have an upper bound in terms of where humans can provide you input. So this is just an example of like what the key uncertainty can look like towards like an end goal. And I think like even the topic today, which is like how to do impactful research, in itself has like a lot of uncertainty. And like maybe like even the presentation today like allows us to illustrate how to break down this uncertainty. So one way to do that is like, well, the question we started with is how to do impactful research, and there are really like three parts to this question, which is like, first of all, what do I mean by research? What really is impact? How can we measure it? And then how do you actually like do things that actually increase your impact with the
Shashwat,
research?
can we ask questions?
Yeah, of course. Yeah.
I think it'd be just so that I personally understand what you're saying. I wanted to again reiterate your difference of solving a very hard, well-scored problem versus reducing uncertainty. Is it fair to say, for example, solving a problem that you have in GPQA or Math 500 is not research because it has like it's very well defined, while research is more about uh, very open-ended uh,
Yes.
reduction in I mean, where problem definition itself becomes a very big part instead of just trying to get to solution. And I'm saying this because I'm trying to refer it to the way our college and school education trains our mindset, which is
Yeah.
almost always about problem solving. We are given a problem in an exam and we have to get an answer. Would you say it's counterproductive to how a researcher mindset should be, or it's
Right.
maybe
So
orthogonal to it?
yes. So I think, yeah, that's a very important distinction. So I think in the talk intro, like in the blurb that maybe Saurabh would have sent out for the talk, this is like, I think, a key distinction, which is that we are not really taught how to deal with uncertainty and how to break down uncertainty a lot in like school and college. Maybe in college with like open-ended projects, sometimes you end up like doing the research process a bit, but most of the time it's like in an exam you get like a scoped out problem, and in some sense you're not reducing any uncertainty there, because we know for a fact that this problem has like a fixed solution. And at that point, like we all like at that point there is like literally no uncertainty. The problem like literally defines everything you need to get to the answer, which is exactly the opposite of what happens in research, where like you start with a very open-ended end goal, like creating self-improving AGI, and then you need to like break it down into small pieces which you can actually approach and solve. So this breaking down into small approachable pieces of a problem that there might, you don't even know if a solution exists, right? For example, a lot of people have shown that like once you know that a solution exists, it's sometimes easy to get to the solution. But one of the key problems with research is that you don't even know if you're solving the right thing and if the problem definition itself needs to change. So like really research is about dealing with this dual uncertainty around like how to get to the solution, which is obviously a part of it. Like if you're good at like solving a problem, then that will help you do research. But in the end, like you need to also recognize when a problem is unsolvable and like how to define it in a way that it becomes more solvable and so on. So that I would say is like more research than like just engineering. And I guess like another misconception there is that which maybe I should like draw a distinction to here, is that people think that research is about doing something novel. And I mean, obviously doing something novel like will reduce uncertainty in a way, because you tested something new and told people what the result of that was. But you really don't need to come up with a novel method to do research. Like uncertainty can also be around like, okay, there are 100 methods out there, which one works best? And if you can answer that, you've already like reduced the uncertainty a lot. Maybe because the next time someone tries to solve that problem, they know what to pick, rather than like them being confused about, okay, now there are 100 methods, which one do I pick? So yeah, I mean, yeah, that's why I want to focus on just the uncertainty aspect of it, which I think is like core to doing research rather than like just developing or engineering new methods.
Got it. Okay. Yeah, that was very helpful.
Yeah, thank you for the question. Yeah, I think, and yeah, guys, feel free to like keep asking more questions.
Yeah, I
So
actually had one. Could I ask on
yeah,
this side? So, I
yeah,
mean,
yeah,
I hear you on this like sort of research as uncertainty, like reducing uncertainty. But how can we actually then reframe sort of just building SOTA on certain benchmarks in these reducing uncertainty terms, right? Because that is also sort of a fairly actionable drive goal for research. Like,
right.
does that?
So about building SOTA on benchmarks, yeah. So I think like first of all, I don't think the goal of research should ever be to like build SOTA on benchmarks. It should always be to like try something that you think should work, and then see whether it works or not, and then report whether it works or not. And yeah, so I mean, benchmarks help us track, okay, are we like make like in some way in aggregate making progress? So I'll come to this maybe in a later slide, where like I don't think like 5% improvement on a benchmark necessarily is very impactful. because yeah, maybe I'll leave that for the slide when I come to it, because I'll go more in detail there. Yeah, thank you for the question. Um, so I guess like one thing I want to show was like what really does this uncertainty look like and how to reason about uncertainty. So uh, the first thing I want to demonstrate here is that there is a lot of uncertainty. Like a lot of people think that, well, AI research is like mostly like starting to get solved, and like uh, we have the answers to a lot of things. Large language models work very, very well. But I really think like that the number of pieces we have solved towards getting to like the end goal, which like here I state as like generally intelligent agents, is like there's so many pieces, and I think the only things we have solved is how to get the model to be like have like general knowledge, which is by pre-training it at scale. And maybe these days we also now know how to like get the model to be good at like algorithmic reasoning, where like you have well scoped out code and math problems, and it can like get like verifiable reward and go and solve them. So maybe these two pieces we started to figure out, but then there's like so many other pieces which we are still uncertain about. And the interesting thing is that each piece breaks down into other pieces. So for example, if you start with the end goal of like AGI, you can break that down into like, okay, we need like good general agents, and we need like them to be intelligent. And both of these things are like very different. They mean very different things. So for example, intelligent would in like most people's like definition of intelligence really is like it should be sample efficient at adapting to like new information and new experiences. And we really don't have much research on how sample efficient language models are, or how good they are at adapting to like new situations. And then within each of these questions, you can like break it down into more and more questions. Similarly with agents, like we know we need like agents to reason about what action to take next, and also to like use tools to like make the problem easier for themselves. And within reasoning, we might have solved like this algorithmic part of reasoning, which is given a scoped out problem, how to like uh, find a solution for it that works. Then you can verify that the solution works. But we haven't solved the other part, which is like reasoning about uncertainty, which is like key to doing like research, right? So that's what I call like Bayesian reasoning, which is like knowing what information to get that you don't have, like seeking information. And also like once you get some information, optimally like updating your beliefs based on that information. And I mean, maybe humans are also not great at this, but like we're clearly better than language models, because so many people have shown that if you give language models under specified uncertain queries, they don't work very well. So all I want to illustrate here is that like uncertainty looks like a tree. You start with the big question, you can break it down into smaller questions. At each level, there is like more uncertainty branching out. And really what like a good research contribution looks like is you take one important sub question here and solve it nicely, so that like you reduce uncertainty on that sub question, and that makes an amazing paper. So yes, like there is like too much uncertainty involved in research, which is what distinguishes it from like, let's say, engineering, or like making things more efficient at scale and so on. But it's really about like, given this uncertainty, pick something to focus on. You get a lot of choices to pick from, because there are so many open problems out there. Within the uncertainty of even like one end goal of like AGI, there are like hundreds of other end goals you could solve for. Maybe like you want to solve aging, or you want to like, yeah, like come up with like better space travel, or whatever you want to do. Towards each end goal, there is like so much that needs to be done, and you get to like pick one of these questions that you think you are the best to solve. So yeah, so I guess like one question that comes up here is, okay, like there are so many things to solve. What do I solve? Like what do I pick? And I'll spend more time talking about in the subsequent slides, but I think like basically what you should pick for is what maximizes your impact. And there's like an emphasis on your here, because like I'll come to it in the next slide. Um, so so what do I mean by like maximizing your impact? What is impact? How do we measure it? So I guess like the generic definition, which makes sense, is that impact is like maximizing your impact is trying to maximally benefit people. Obviously, that's like ill-defined, and like doing the typical research process, let's try to define that more. So one thing to note here is that when I say that impact is like maximally benefiting people, I'm not discussing like also like the learning outcomes. So for example, when you do like you could do a research project just so that you reduce your personal uncertainty and get to like learn like a few important skills, or like you try to build career capital, which is like putting out papers and like showing the world that you're good at doing AI research or whatever. This I won't discuss too much right now. We can take it like towards the end of the talk as well. But yeah, so what I mean by impact right now is like maximally reducing, like in the case of research, it would be maximally reducing uncertainty for the research community or like for the AI community at large, including like startups or like engineers and so on. So I guess like one way to measure this is first thing, like let's say you put out a paper, right? How do you know like how much impact it has? The first thing to measure is like how many people actually touched your work in some way. This could be like touching your work by reading your paper. It could be that your paper got integrated into like Google's next model, and it improved the model by, let's say, like 1%, and then like that impact got like really amplified because like millions of or billions of people use Google models every day. So so the first question to ask is how many people does your work touch? And then the second question to ask is how much does it actually improve their experience? Like how much does it benefit them? And both of these are like before you start your project, or like even when you put out your paper beforehand, it's very hard to like predict what each of these will be, but you can do things that increase your chances of like touching more people and benefiting them more. And like part of why like people think like research is hard is because this question is very hard to measure. Like it's very difficult to know what to solve or like what problem to try and tackle, and picking that is what people call research taste. And how you pick a problem really depends on how many people you think solving this problem will impact, or like how much it will benefit them. And I guess like the question I ask myself for the first one, like even when I start a project, is let's say this project gets completed, how many people will learn something meaningful from it? Like, is it going to be like a very, very specific community? Like, for example, people looking into like knowledge graphs and like a specific property of knowledge graphs? Or can it be like, ideally, I want like the whole AI community should like have something to learn from the research I did. I want to like reduce the uncertainty for as many people as possible. And the second thing to ask here is like, like so how do you even measure how much it will benefit people? I guess it's hard to know what really people want and what people actually will like use and so on. So I guess the question I ask myself in this situation is like, how much will it help me? Like if I'm going to do a project which doesn't even like help me in any way, and I'm not going to use it in my subsequent work or use it to inform my subsequent work, then I think like that project is not very useful. Because if as the builder I myself am not using it, then why would I expect anyone else to like make use of it? And so the first question to always ask is how much it will help you, and then like you can start reasoning about, okay, am I like some edge case user who's the only one that will benefit from this? Most probably this is not going to be true. And then you can see like how many people does this like use case generalize to.
Yeah. Shashwat, I have a quick question.
Yeah.
So how would you contrast this with something which is more curiosity driven, where because this is like a point of view on impact, but some people are just curiosity driven, even if it doesn't impact anyone. Do you have any thoughts there?
I personally think that like I think if you're curious about something, uh, then also like it's very likely that other people are also curious about something, or will that thing, or will become curious about that thing. Obviously, like there is sometimes some gap. For example, you might care a lot about like one specific like algorithm and how to optimize it by like 1% more, and maybe like people don't use that algorithm at all, and then like yeah, it becomes more curiosity driven. I feel like because there are so many problems to solve out there, even if you're curiosity driven, like all of these problems are really important, so you can pick the one which is both impactful and also like sparks your curiosity. And you should pick something which you are actually like passionate about, because like I said before, like you want to maximize your impact. And if you just pick something that you're not passionate about, someone else will do it a lot better than you. So
Hmm.
like
Um,
yeah.
yeah. Okay, makes sense. But I heard a follow up also on this.
Yeah.
I mean, if we go by the framework of impact, I think a lot of people will converge on some attractor points in that graph, and that's where the whole popular
Yeah.
subproblems become like chain of thought and so on and so
Yes.
forth. And
Yes.
how do you sort of
Yes.
sort of normalize against the fact that everyone is jumping to do the same thing?
Yes, so I will come to this in my next slide. I think that's a very good question. So one thing I need to define here is like what really is impact. Like one thing to keep in mind is impact is counterfactual. If you do something that someone else would have done anyway, then that's really not your impact, because I mean, then even if you didn't do it, someone else would have done it, and the world won't like change. So you really need to pick something which like meaningfully changes the world in a way that people wouldn't have gone there if like you hadn't done it. So I'll come to this in like more detail
We
soon.
have more questions. Rishad, do you want to go next?
Yeah.
I was gonna ask you, how do you define impact in the short term versus the long term as well? Because some research will have a effect after many years. Or on the other hand, some research might give immediate results.
Yeah, that's a very good question. I think like this is like the hard problem to deal with. So like one thing I was going to come to next, which was going to focus more on like short-term impact, was that like maybe I'll answer the question first and then come to it. So so I think this is like a trade-off. Some things like some things help towards the end goal, which is uh like let's say the long-term impact you're aiming for is like helping create like boundlessly self-improving AGI, which is like my personal goal. Then uh yes, some problems won't matter towards that in the long term, and you should like hedge your bets in a way that like so the problem with long term impact is that it's like very hard to reason about. It's very difficult to say whether your research will be relevant 10 years from now, because uh like it could be that like your research was on LLMs and then someone just came and like put apart that entire paradigm and shifted to something where your research doesn't apply anymore. So I think that's a hard, and B, like one thing that people have recommended to me is like have one project that is like your long-term vision, work on it slowly, have more time for it, like think about something that is really hard to solve and keep working towards it. The other thing is that on the side, keep smalling smaller problems which also keep giving you short-term impact, so that if you like somehow were wrong about your long-term vision, you still accumulate some impact or like some career capital or whatever you're optimizing for in the short term as well. Because like I said, like the uncertainty looks like a tree, right? So I mean, you could have like the long-term impact will be the higher nodes in this tree, but you can like by solving like the lower parts of the graph here, you can keep having short-term impact and align it with your long-term vision.
Okay. I do have another question. Shashwat,
Yeah.
sometimes just new questions crop up while you're doing something else. I mean, the
Yes.
process that you're describing is very top down. It seems almost too perfect. But in my experience, there's a lot of randomness and noise involved
Yes.
in what you end up ultimately doing versus where you start from. So, do you have any thoughts on that?
So I think that it's a trade-off. The first thing is you should ideally try to keep focus, which is like if you start with a long-term vision, unless something came up which like really invalidates your long-term vision, it's good to like keep working towards one goal. At the same time, I struggle with this a lot. Like I don't think like I have like a very like when people ask me what my research direction is, I can only come up with like I want to do something that like helps models like solve this general problem, which is like self-improve and be like good agents and so on, be intelligent. And I'm interested in everything that comes under that tree, honestly. Like so I feel like yeah, it's just that like if you keep changing things, then you won't have impact anywhere. And one of the things that I wanted to I have in my slides later is just that like people will know you by the one thing that you did very well and not the 10 things you did like occasionally well, or like you like the 10 good papers you care about, people won't know you for that. People will know you for that one paper that really went viral, changed everyone's mind about something important and so on. So uh while you should try to get like these short-term impact things, it's good to like have this one goal in mind, which is like going to be the thing you're known for. And
Yeah,
I
I
think
think on that note, I just keep. I mean, suddenly the name I think Alex from AlexNet popped up,
yeah,
who sort of was first author on AlexNet, and it I think 1 lakh citations or something, and
yeah,
never wrote a paper again, and
yeah.
still his name is just everywhere.
I think if you open like any top researcher, you will find that maybe like 10% of their work has like 90% of their citations or something. So it's in fact, like I think I had like in like an older version of these slides, I had like the screenshot of like Jimmy Ba, who's like 80% of his citations are from one paper, which is Adam. And that paper is like very simple and elegant. And at that, like in hindsight, it's almost obvious if you like read through it. But at that time, like it was so impactful. And that's why also like some of these things are hard to predict. You don't know when your break will come through. But so it's good to like keep trying to do good things without thinking a lot about like that like, getting that one break. Eventually you will get it, hopefully. But at the same time, it's good to keep focus, I think. So it's like, yeah, it's a hard trade-off. I'm struggling myself to like balance it perfectly.
Okay.
Yeah. So I guess like that was a lot of abstract things. So I'll try to like intersperse the slides with like some practical tips on how you could like reason about like these things like in practice. So one thing I suggest, like especially when you want to like develop a research taste and get a feel for what impact is and what are the impactful questions that the community is uncertain about right now and so on, I would say one way to do that is like follow high taste people on X and Google Scholar. So I think X, a lot of people already would be doing, but if you aren't, like I would really reinforce that it's amazing how like sometimes I just think about it and feel like very surreal about the fact that like these people are like when you start as a researcher, a lot of these people are your heroes, and you get to like listen to what they're thinking about right now, at least for some of them who post actively, right? Like you get to hear what questions someone like 10,000 miles away from you is thinking. And these are the like this could be someone who's at the frontier of the field, right? So you almost get like this head start by getting to know what they are thinking about if you just like follow the right people on X. So I think that's very powerful. And I mean, so that's why my X, I just like try to curate very heavily, where like I only follow people whose like research or like work I find engaging, or they post like some interesting tweets or so on. Like and the second thing was like the Google Scholar thing. This is like I think much less common. Like I think people don't even know that you can follow researchers on Google Scholar, and basically you will get an email every time they release a new paper. Obviously, like not every researcher is worth following because you don't want to be spammed in your emails. But I think some researchers consistently put out like really high quality work, and just like since there are so many papers out there, it can be sometimes difficult to discover their work uh, on your own, like on archive or something. So I find it very useful. Like I keep like curating this like list of people I follow on Google Scholar, where like every time they release a new paper, like I get something in my inbox, and at least I read the abstract, right? So I know what they're thinking about right now. And waiting for conferences is probably not the right way for this, because the conference will happen 6 months later, right? Even if you get to visit, by then like the community moves on, like AI moves very fast. So like following people on Google Scholar is really like people won't talk about what they're doing maybe before they publish the paper, but once they've put it on archive, you can get the notification immediately. So you can shape your research around what the frontier currently is by doing this. Um, yeah. Um, so I guess this brings me to like the next like concrete point about like how I think about impact. So we discussed this SOTA benchmark thing, right? Like, and I think like I mentioned that like I don't really like think that like increasing SOTA by like let's say a few percentage points on a benchmark is like really that impactful. And why I think this is that like if you think about it, like if some solution improves the performance on a problem by 5%, it may be at like 5% to the impact of like that specific whatever impact that benchmark has in terms of generalizing to the real world. Maybe that solution like improves like 2 3% or 5% on it. So like yeah, like improving the solution by a bit only like marginally improves your impact. And also the other thing is that when you start a research project, it's usually very hard to predict. Like let's say you had an idea, right? You read a paper and you felt like, okay, I can change this one thing in the paper and it should improve things. It's very hard to predict how much like this new solution that you came up with or improved solution will a like how much will it actually improve on the baseline, and b like does it even generalize to other problems. Like it could be that the solution you're improving is like too specific to a single problem, and then like what you do doesn't end up like generalizing to like a completely different problem or even like related problems. So that's why I feel like maximizing performance on a single benchmark or like even like 3 or 4 benchmarks doesn't really like say much. It doesn't really reduce the uncertainty by a lot. And what I think is more important is picking a problem that you're passionate about, because no matter what you do, like you will end up spending more than 6 months on the project. And like basically the maximum impact that you can have in this in any project is kind of like upper bounded by how important your problem is. If you pick a problem that's not very important, then you can work really, really hard, and in the end, like maybe people just don't care about the problem itself, and you came up with an excellent solution, but like people don't even want to hear about the solution because they don't find the problem like interesting or important to them. So I guess like this is like one of the failure modes of like purely curiosity driven research, where you might end up like picking something which picking a problem which is not very important. And I think solutions are malleable, right? Like I think like in the end you should just pick whatever works best, not like you shouldn't be like, okay, this idea sounds very elegant and I will like no do like spend all my energy and on trying to like you use this idea for a solution and improving it. Instead, like what you should think about is what is the problem you care about, and then like just pick the best solution that works on that problem. So another thing is that like if you look at even if you track citations, which is a noisy metric of impact, one thing you will notice is every time a paper gets highly cited, it's because it highlighted a new problem to the community, and then either solved it or made like an eval out of it and said that, okay, this is an important problem that the community needs to improve models on, or like just improve research on. So I would say that like highlighting like these new questions allows you the opportunity to like really go from like 0 to 1 on that problem in terms of impact, whereas just improving like marginally by doing some hacks or tricks on like a specific solution or benchmark will only like make your impact marginal. So like again, like if you look at the problem tree, I would suggest like pick something on that problem tree which is like scoped out and like a complete sub question that people haven't thought about before, and then you try to like answer it as well as you can. And obviously like the lower I don't have the tree here because it was too big, but like the lower the depth is, like basically the less assumptions you have to make to get to your problem, the more your problem is general and the more it will be impactful.
Sorry, the lower means closer to the root node or
closer to the root node. So just to illustrate this, like
I have questions. Mayank has a question.
Yes.
Mayank, you want to go?
Hi,
Yeah.
man.
Hey, Shashwat. Yeah.
Long
So you mentioned improving on benchmarks. Does that not validate a theory if you have a theory of implementation? Even some marginal improvements of benchmarks still show that you are meeting the SOTA.
Yes. So what I meant was that the goal should be, like, I completely agree that you should benchmark things to validate what you are trying to say. Otherwise, like you could be like building castles in the air. But what I meant was that the focus should not be on improving on the benchmark. The focus should be on the question that you are trying to answer. In the end, if you answer a question and that only improves performance on the benchmark by 2%, I don't think that's very important. It could be that the benchmark doesn't even, like, maybe you found a problem that the benchmark doesn't really measure. So I do agree that like ideally you should find a benchmark which really measures your problem, or create this benchmark for people, which can be very impactful. But the focus should not be on improving like GPQS scores. It should be on like solving new interesting questions which people care about.
Yeah,
That's
I
all I'm
just to build on that. I agree with you. I think it's just the reality distortion field that comes about on social media, where let's say if some models are beating some benchmark, it feels like research, but it's not really research, right? I think that's what Shaurya on the chat is also saying. It's more of an engineering problem than a research problem. Of a lot that gets trended on social media, and we feel that SOTA is all that matters.
I feel like this is true for the big companies. Like they have to like start with the benchmark scores in the first picture that they show people, and that's fair, right? Because like their job is to get product out, so they're really doing more engineering than research sometimes. So like in the end, it does somewhat matter to them what the benchmark score is, because it kind of validates their engineering. But as a researcher, maybe your goal is slightly different. anyway, you're not going to beat the big labs in terms of like achieving SOTA on a benchmark. Like that's going to be very hard. If you can pull it off, like kudos to you. So your goal should be like trying to answer an interesting question. And I do think that like when people do answer a research question, that also gets like a lot of virality on Twitter. Like I have seen, like if you start your tweet with like, how do I do this? Or like models can't do this, how do I solve this? So even like if this is a question that resonates with people because they've seen this problem before and they've thought about it, but they didn't do anything or they didn't know how to solve it, they will like repost your tweet or like it or comment or so on. So I do think like if you can attract attention to your question, sometimes just answering a question can also be like very useful.
Okay, makes sense.
Yeah. So this is just like an example of like trying to illustrate like the depth in the tree process of like measuring how important is the problem you're solving. So like I just took like examples from two recent papers I did. So the first one, basically like if I had to explain it to you, it's very simple. We have like so many models and techniques out there. We wanted to see how similar they are to each other. And we measured it in like, we made one assumption to measure it, which is that uh, the model makes a prediction among a bunch of choices, like a classification problem or a multiple choice problem and so on. And then we showed how you can measure similarity between models or techniques given this assumption. So again, like if I had layered more assumptions in, then my paper
So
would have become like,
what was the assumption?
uh, so we came up with like a metric to measure model similarity, and the assumption, like the metric only works if you are measuring similarity over a problem where you have like a set of classes, like a finite set of predictions that the model can make. It doesn't work for open-ended generation.
Got it. Okay, makes sense.
If we had solved open-ended generation, then I could remove the like one node from this tree, and my project would have been way more impactful as well. And similarly, in the second part, we started with like a very simple question. There are so many models and techniques that people use. How do you even evaluate which one is better? And then we showed that like if the answer is like if the response is open-ended and like the final answer is unique and short, which is true for like most benchmarks, we showed that like how you should do these evals is basically using something we call answer matching instead of using multiple choice evaluation. So again, like we try to like in every paper I write, I try to think of like what are the like starting from the top node, what are the main assumptions I'm making, and reducing these assumptions and like trying to like keep it as close to the top node as possible. Because
So, Shashwat, I have a question. Let's say on the second one, I think the naive response to the question or subnode, how to evaluate which one is better, is that, of course, you have benchmarks. Of course, you know GPQA, which model is better and worse. So I'm curious your thought process on why and how did you feel there's still uncertainty and you went about and trying to think of another method? Because my first response would be, hey, I don't even need to bother with this. The community knows.
So the idea was that in the existing benchmarks, what format should you evaluate the existing benchmarks on? So currently, like most of the popular benchmarks, if you look at them, are going to be like multiple choice. And we showed that like fundamentally multiple choice is flawed for XYZ reasons and what you can do instead. So the idea is that we like this is a broad enough base that I can, now that I have this contribution, I can apply to like all benchmarks.
Yeah,
that use
my
multiple
question was, how did you get a sense that there was large uncertainty? Because MCQ seemed like it was doing a reasonably good job.
Yeah. So, I mean, I think, so how do you, yeah, I guess like that comes to how do you identify problems? And I guess like one thing was the fact that, I mean, how this project actually came about is like another long story. But maybe one thing to notice is that like maybe if like a lot of people here would have given JEE, and the Indian education system makes sure that you take a lot of MCQ tests. And one thing you would have noticed maybe earlier is that even if you can't solve the problem, sometimes you can like either verify just the options by plugging them in and seeing if they work, or you can sometimes there is like in the options itself there is like one option which is the odd one out, and you can ignore the question entirely and pick the option which is the odd one out, and that will most likely be correct. So like I guess it came from like this fundamental place of realizing that MCQs are not a generative evaluation. They measure like something more like verification, and people have been talking about how verification is easier than generation. So I guess that was the starting point. And then we try to come up with, okay, how do we demonstrate this in like a very convincing like shocking way or like surprising way.
Okay, makes sense.
Yeah. So again, like trying to break down the problem of like how to pick a problem more. So yeah, the first thing, like I mentioned earlier, like you should ideally be the user. Like don't try to solve something that you don't face, because then there's no clarity on whether like someone else faces it as well. Like it's very hard to predict what problems others are facing compared to what like you are facing yourself. The second thing was like, okay, let's say you came up with an idea. Before you start working on this idea, think about like if you achieved the best version of this idea, like whatever your vision for this paper or project or whatever is, you put it out there. It's like among like this pool of like 1,000 papers that come out every week. Would you yourself have read your paper if you saw the title and abstract? Like, if the answer to this is no, then maybe you should not spend 6 months of your life working on this problem, because you don't yourself care about it. You wouldn't have read it yourself. So really, like this helps you prune I mean, I think it's very easy to come up with ideas, right? Like every time you read a paper, you can easily list like 3 more things you could do on top. But what you should really think about is like, would I have read this paper if I saw it on like archive, or would I even see it on archive in the first place? And if the answer is no, then just don't work on it. It's not worth your time. And the other thing that I think Paras brought up is like impact is always counterfactual. So don't make the mistake. Like when I say maximize impact, I always work under this assumption that it's not trying to solve the most popular problems, especially if like thousands of people are already trying to solve that problem. Then like the expected impact you will have is low, because like someone else might do it before you, and then like you don't even get to get your paper accepted. But the other problem is that even if you manage to beat them in this race, right? Like think about the fact that like if you hadn't like done this, someone else would have done it maybe like 1 week later. And at that point, like the impact of your project was really like the 1 week earlier you put out this like result in the community. And I don't think like putting some result out 1 week earlier like really like changes things in the long term, right? Like it doesn't really have an impact. It's not like we're solving like emergency problems like COVID-19, where putting something out 1 week earlier really matters. So yeah, like always like try to work on problems that you think are neglected in a way that you realize that this is important. Maybe it was important for you. Ideally, it should be something that's not very important for the frontier labs to solve. Like if you're trying to solve something which is like on the OpenAI roadmap anyway, then like it's very likely that their next model will just blow your solution out of the water, because there's like they have a lot more resources and like very smart people working on the same problem. So always try to pick something which is not like the immediate next goal of like Google or OpenAI. Maybe pick something which they would care about 5 years from now or 2-3 years from now, and try to focus on that, because then you have like more time to like work out a solution and also put it out much earlier than they do. And obviously like the last thing to reason about is like tractability. Like don't go for like extremely ambitious impossible visions. I mean, it's good to have like a long-term vision, but then for a single project, always break it down into like something that you can actually achieve in the next 6 months. And always think about, okay, like what do I expect would happen like reasonably if I put in like a good amount of effort that I am able to. Where do I think I can get in like 6 months? And you can go surprisingly far in 6 months. Like I think people underestimate how far you can go with like enough time. But so always like try to pick ambitious problems, and like, but always like also like don't directly aim for AGI. Pick some smaller question in the problem tree, solve that first, and then like go up from there.
Shashwat, I have a quick question here. How do you differentiate between uncertainty that I have versus uncertainty that a community has? A lot of times, what we feel is uncertain. It's simply just our lack of knowledge. So, do you have any tips there on
Oh
background
yes,
learning? Or
I think like, this is like I guess like just like the access to information problem. If people already know the solution, it should be there on the internet somewhere. Just like go and like so I guess the problem becomes, how do I find this information on the internet? Like if I just put a naive Google search, maybe I won't find it. I think this information access problem is something that like Google and OpenAI are solving now with like deep research models. So I guess like at some point they will solve it. if like put in some reasonable effort into seeing if like the knowledge doesn't exist, and if it exists, then use it. If it exists and is not convincing to you, then maybe there is some scope for you to like actually reduce more uncertainty there. And the best case scenario is you came up with something which people haven't really solved, and then you can work on solving it.
Okay, thank you.
Okay, so I talked a lot about like picking a problem, and let's say now like you have picked a problem, and now how do I like execute a project? Like how do I do actual research? Like I mean, picking the problem was like I think 50% of the contribution in like doing research, maybe even like more than 50%. And it's surprising that people spend very less time on it. Like sometimes people expect they will pick a problem, like including myself. Sometimes I start feeling like uh, I start feeling like I'm clueless 2 weeks into like not being able to like scope out my problem. But really, I think like it is worth spending like a month or two scoping out the problem before you try to solve it in the next month or two, because in the end, most of your impact is coming from the problem. But let's say you've done all of this, like you know what you want to solve, and now the question is like, given like this vision for the project, how do I like execute on it well? Let's say like the research direction you picked was I want to like improve AI at doing research. Now what, right? Like, so the first thing is like, yeah, like I mentioned before, scope it out into a concrete sub goal that you can do in one project. And the way you do this is just you keep decomposing it. So for example, if you want to make AI better at doing research, research entails like different capabilities. One is like literature review, which the current deep research models try to solve. The other is like executing solution, which like given a scoped out solution, just like implementing it, which again, like maybe Cursor or like the current coding agents try to solve. And then there are like other parts which we currently don't have a great solution for, which is like generating hypothesis. If there is like some existing result, trying to like show when it doesn't work, which is like falsification, or like even the problem of like prioritizing which problem to pick or like where to allocate resources and so on. Like these are the this is how you like decompose like the grander problem into like smaller things, and then you pick one of these and try to like break it down further. And again, like in the end, you want to scope it out to a level that you've identified one key uncertainty. The way you do this, like I discussed before, is like first try to like see what the literature has already done. And the way to do this is maybe like first starting with like one deep research query, reading like existing papers and blogs, then like coming up with follow-up hypothesis, then seeing if they have already been solved and so on. And I guess like another way people do this is like once you find one good paper, you can follow its citation graph, which is like the papers that cited it, and see if they already like solved your follow-up question or like so on. And one thing that's actually very useful is like when you're starting a project, talk to like the relevant people, just shoot them a cold mail and be like, I'm trying to I'm trying to work in this area, you've written this paper in this area, and it's very likely they will know a lot more about the problem and what's missing there than you do, like because they've been thinking about this for 1 year, you've been thinking about this for let's say 1 week. And once you talk to them, either like they will already have like 5 problems in mind which they will like maybe share with you, or you can go to them with like, this is what I'm planning to do, what do you think about it? And because of their experience, it could be that they've tried it and they give you some tips, or it could be that they think that for some fundamental reason that you had overlooked, it's not a very important problem to solve. Like before spending 6 months of your life on like a project, it's always good to like talk to the relevant people and find out what they think. And yeah, like then like let's say you did all of this, you came up with a clean hypothesis, then the first thing to do is like try to like do quick validations of it, like basically run the smallest experiment possible that would either invalidate your hypothesis or show like early signs of convincing evidence. And or again, like once you have a problem in mind, always first like check whether there is like you have enough compute to actually do this project. There is data out there that is easy to collect and use. There is a benchmark where you can demonstrate like you can validate your own results to see if things are working or not. And maybe like if the data and benchmarks don't exist, creating that is a contribution which is very important. And then maybe you should focus more on that rather than like coming up with the solution and so on. Like yeah. And again, like all of this is a lot. So another practical tip is just like throughout the research project, it's good to like organize your thoughts. So I personally use Notion for this, and I've just like put some screenshots of my workflow. So for each like project that I start, I like make first like a main Notion like project page for it, where like I put like what my progress. So I'll make like maybe 2 pages, one with like all the important resources that are already out there related to this problem, where I keep dumping new things as I find them. And so for this, another interesting thing that I've like discovered over time is that whenever you read a paper, it's very easy to like, you'll think that, okay, you will remember what the contribution of this paper was, but then 3 months down the line, you will most likely completely forget that maybe this paper already tried to do something that you are now struggling with. So what I always do is like, I try to maintain like every time I read a relevant paper to my project, I try to maintain like maybe a 4-line, 5-line summary of what I observed, so that later I can come back and just read the summary and know what the paper did and not have to like go through the paper again. So that's one thing. And then the other thing is like, yeah, I mean, like as you do a project, you keep coming up with more and more ideas, and it's impossible to like test everything immediately. So just like keep noting down your thoughts and putting it into like some like list of tasks, and keep track of what tasks that you have already done, what tasks you are currently doing, and just like organize things nicely in whatever platform suits you the best. Um, and then the last thing here is like, always try to make a meeting agenda, because let's say you have like, let's say you're working with a supervisor or like collaborators and so on. I've seen like many times people go into the meeting with like no clear like thoughts on what to discuss, and then the meeting ends up being like very unproductive. Instead, if you like take 15 minutes before the meeting, try to compile the bullet points that you want feedback on, and then like use that to like structure the meeting. Like start by asking the other people questions, then you will get like a lot more out of the meeting. And really like I guess like with research, meetings should not be about trying to show people what you've done. Like it should never be an update about oh, I did all of these things in the last 1 week. It should be more about, okay, this is what I want your feedback on, and like this is what we should discuss and brainstorm. So identify your key uncertainties and like focus on them in the meeting, rather than trying to prove that you put in the effort. I think like it's like good to just assume you put in the effort if you've got to like the important questions over the week. Yeah. And then like the next thing, like I got this question in the Google form, so I think it's like an interesting question to discuss, which is like how to pick an experiment. Like let's say I figured out like this is what I want to do, and now which experiment do I run first? So one, like I have like this link in the sources of this article called Research as a Stochastic Decision Process. The main ideas there are like, the first experiment you should run is usually ones that would invalidate your vision, or like if you're making some crucial assumptions, the first thing you should do is try to fail, and fail as fast as possible, because in the long run this will save you a lot of time. If you find out early that your idea doesn't work for some reason, then then you can just move to a different idea. There's like hundreds of ideas out there. And uh, again, like this also like ties in very well to like reducing uncertainty, which is that always try to like first run the experiment that you're most uncertain about in the outcome and is most important to your vision. So yeah, like basically try to maximize information per unit effort in some sense. Information is in terms of how much it reduces your uncertainty. And obviously like it's good to fail fast. So you don't start with like trying to complete the end-to-end project, because that will like give you full information. Rather like start with something very small that you can test very quickly. And another problem, like usually what sometimes people end up doing if they don't think about this carefully, is they start going from easiest to hardest. So if they have like n things to try, they'll first pick the most easy one and check that. And it might even be something that just like confirms like it basically reinforces your beliefs. Like we have this bias towards looking at evidence that reinforces our beliefs rather than invalidates our beliefs. So don't go from easiest to hardest. And again, like don't go down rabbit holes, because again, you will keep getting like interesting ideas as you do research. But what is important is just like keep writing them on like Notion or wherever you are like maintaining notes, and try them later. Like most of the rabbit holes are good cherries on top, but they are not important for your main vision. And just like, yeah, it's important to focus on what's the most important uncertainty towards the end goal, and try to like work towards that. Of course, if there's like some dependency that you need to build irrespective of what you do in the project, like for example, collecting data or finding a benchmark or building a benchmark, then you should obviously do that first, because that you will need throughout the project. Yeah, just continuing on this line. Again, like it's very important to like iterate fast in your early experiments. So like uh, try to look at the smallest scale that will give you good signal, and like the quickest experiment that will give you good signal. Iterate there with all your ideas for as long as possible, and then maybe like scale up to a bigger model or like a bigger training data size or something. And another problem that I also often have is like I overthink, which is like I keep thinking about like conditionals in the sense of like, okay, if this is what I see, then I will do this. If I don't see this, then I will do this, and so on. And most of the times this is just counterproductive because you keep like thinking deeper and deeper. And in the end, when you run your first experiment, you realize your first assumption was wrong. So in general, like try to have a bias towards just running experiments and just like getting things done instead of like thinking more and more and trying to like broaden the scope of your project. And yeah, I mean, practically in ML research, we are mostly compute bottleneck. So try to keep the GPUs working all the time. I guess one thing I want to highlight, if most of you have taken an ML course, most of the courses don't talk about the bitter lesson. I think that's the most important principle in machine learning, which is that uh, how humans do something, like baking in human intuition into the system and human constraints, is not important. Sometimes like you just need to let the machine do its thing, like burn compute and like let search figure the most optimal solution out. So I won't spend a lot of time discussing the bitter lesson here, but like if you're doing AI research, this is the one thing that you should definitely know if you don't know about it. And I have the link to this in the references. And then I guess the last principle is that like try to do something which is like try to simplify what you do as much as possible, because simple generalizes and simple is also easier to use for other people. If you do something complex, then you will like every time you add another layer of complexity, it's just one more confounder that like who knows why your like new solution works. It could be because like if you have 10 components, it could be because of any of the 10 components. And really like what you should try to do is like ablate all of them away and like make it as simple as possible. A practical tip on like actually doing this abstract process is just like make a overleaf draft very early into the project, or like whatever place you're writing the paper. Write the outline of what the goals of the project are. Like I have an example from an ongoing project here where we just put in the section headers that these are the problems that I'm trying to solve, and then like then write the subsection headers, and then like iterate from there, picking like whatever is the most important experiment. What you will realize in doing this is that among the 100 ideas that you have, 95 of them are like just cherries on top and can wait for later, and like you can go down that rabbit hole at the end. Most of them don't matter for like the main vision of or the main message of your paper. Yeah. Yeah. And in the end, like just like keep things simple. And when you write a paper, for example, again, like it helps to start with this is why I'm going to show you what I'm going to show you next, and then like describing what you do. Like a lot of people write papers in a way that, okay, this is what we did, this is what we did. But when I'm reading the paper, I don't have any idea why you had to do all of this. So always start first with like motivation, and like every paragraph should start with the motivation of what you're going to talk about and why, and then try to answer that, which aligns with the philosophy of like describe the problem first and then like think about a solution. Yeah, I guess like one thing was that another question that I think Paris mentioned was, how do we know when we are done? In research, I think there's like, you can go on forever. So it's important to like know when you have finished a project, because like in the end, like practically you can only reduce the uncertainty to a certain amount. You can't like all like, it's very difficult to like have a conclusive, like fully general principle that you find in research, especially in like empirical research. It's not like Newton's laws of physics, which will have like zero uncertainty around them. Even there, like people found later that like, for example, quantum mechanics like invalidate some of the assumptions and so on. So in general, what I try to do for like this practically is like set a deadline. And there are like 3 to 5 major conferences in AI research every year. Just pick one deadline. Let's say you decide that for this project, I want to spend like at most 3 or 6 months, and then try to stick to that deadline and try to do only what you can achieve by that deadline. Another useful thing, because deadlines like really improve your productivity and keep the end goal in mind. it's always good to have like an additional deadline, which is like, let's say, a workshop, because workshops in conferences have like a much lower bar for acceptance. As long as you have like any valid research contribution, mostly it should go through a workshop. So it's good to have that as a earlier deadline for like, okay, I will write up a draft and submit by here, and this will allow me to like then like focus on improving what's the most important things to improve on the draft, and also like send out the draft to like, once you have a draft for a workshop, you can send out the draft to like a lot of people for feedback, because maybe in like doing the project, like we start assuming things because we've thought about them for long enough, but when fresh eyes see them, they like sometimes think that like they find ambiguities that you almost assume to be trivial, and maybe that's like an important ambiguity that other people have, like this is something that others are uncertain about, and they will tell you that, and then like you can use this feedback to like reduce uncertainty there.
Shashwat, I didn't understand, what does workshop help with?
Oh yeah, I was just saying that, so in general, like setting deadlines helps, so that's the first point, and workshop is just like another deadline before the main conference deadline, or before you put the paper out on archive for everyone to see.
But if you, okay, so you don't submit to a workshop, but you use workshop
No, you
as
submit to a workshop. If you know you won't submit to a workshop, you won't take the deadline seriously.
okay, then I mean, if it's a more important paper, wouldn't you want to submit it to a main conference and not a workshop?
So yeah, okay, sorry, I think I overlooked this. So workshops are mostly non-archival in machine learning. So the idea is that you can submit something to a workshop, and if it gets accepted, you can still keep submitting it to a main conference later.
Oh, is it?
Oh yeah, yeah. So it's not like you submit to a workshop and now you can't resubmit it anywhere else.
Oh, I didn't know that.
In fact, you can submit to like multiple workshops. So I've seen projects where people first submit a very early version to like a workshop 1 month late, 1 month from starting the project. Then they submit to another workshop 3 months down the line. And then maybe the final paper comes out 6 months down the line. So it just keeps you like accountable on the deadline if you know you're going to submit somewhere. And it's always nice to have like that intermediate like satisfaction of getting like an acceptance, even if it's a workshop.
Interesting. Okay, that's very useful.
Yeah. Yeah, and in general, like again, like I think a paper is like finished and done and good if you have one conclusive important takeaway. A lot of people like, even when I started doing research, I tried to like fit in like 5 different interesting things I liked into the paper, and what really that does is that it distracts from the main message, and then people start like attacking the weakest links of your paper, which are like weak contributions. So really, like just like once you have like one conclusive result, just focus on like that result and write a paper, and try to like fill in the gaps to like make that result more convincing. Keep the rest of the things for maybe like a subsequent paper. And in hindsight, like one thing that happens to me is that like after working on a project for 3 months, I feel like whatever I did was obvious, but I think that's not true. Like what my advisors keep telling me is that when I started the project, I wouldn't have been able to predict what I know now, and in that sense, I've like reduced uncertainty. I have like maybe a conclusive important message, and that in itself is progress and like good enough to like maybe like write a paper about. So yeah, like in general, like don't feel like what you're doing is very obvious, because if it was very obvious, maybe you wouldn't even have like run an experiment to test this. And yeah, like since the end goal is like to reduce uncertainty, like obviously try to run like careful ablations that 80-20 the sources of like key sources of like error. So there could be like 5 things that are confounders to your experiment. Try to like test all of them, but in a, again, like your time is limited, your budget, like your time and budget of resources is always like a constraint. So try to come up with the simplest experiment that kind of like gives you signal on whether like some source of error is really important. In the end, like you can't convince everyone. Like the reviewers will always come and be like find like some gaps in your research, and I think that's okay, because like the point of research is not to like solve an entire problem in one go, but rather to like reduce uncertainty and make progress. Yeah, and then like let's say our project is finished. Again, like one thing people like researchers don't care about, maybe like other people think this is obvious, but researchers often forget, is that once you put out your paper, the impact of your paper has just started. Like it's not the end of the project, it's like kind of like the beginning of the impact. So it's very important to like market your paper, because in the end, like the impact comes from how many people you touched. And maybe you put out like an excellent paper, but it's like too hard to read, and that's why people don't like really understand it and don't use it. and that like completely kills the impact of your contribution. So in general, like once you are finished with the project, make it as easy as possible for people to understand and like use your contribution. For example, like release reproducible code, make it very easy to run, like you like use UV instead of conda if that makes it easier for people to reproduce your result and extend it. I try to release all the data that you collected in the process. Even like the model outputs, I think are very useful. Like if you got like, instead of just like putting out, let's say the code, also put out the full outputs that you produced from the models in like trying to run the paper, because maybe someone else will find this very useful. They can just analyze your data and write another paper about it. And these days you can just wipe code a web page. This really helps with like search engine optimization. I've noticed that like, for example, for our model similarity paper, we made this website, like just a GitHub page, which is free, like modelsimilarity.github.io. And now if you Google search model similarity, this is the first thing that shows up. Our paper doesn't even show up anywhere. So I think for some reason, search engines like websites. So just like make a web page if it like suits your project. Mail or like message your paper to everyone who you think would be interested. Sometimes this can be really helpful, because then it's very hard to find good papers. And if you have like a good paper, I think people would be happy to know that it exists because they might find it useful. And yeah, and then like, let's say you get to go to a conference, like your paper got accepted, you go to a conference, try to spend more time to like in like meeting people, because this is the only opportunity you will have to like actually talk to them in person, maybe because they live like one continent apart. And focus less on the talks, because in the end, like I've noticed that mostly what people talk about in talks is something that they've already put out like 6 months ago on like some paper or blog. Sometimes talks are good to like get a quick high level overview, but mostly they are stale. And like in AI, the community has already moved on by the time of the conference. So use it more to like build connections. Some examples of marketing that I've done for like my past work. So I think what really like made me realize how important marketing is, like I worked on this like big project with like this team of people, and the PI there like got someone in Time to like write an article about it. And I think most people know the paper because of the Time article, and no, like I don't even think like 10% of those people actually opened the paper. So obviously like not every paper can get featured on Time magazine, but like this is just an example of like sometimes the audience you can reach out to matters way more than the actual content of your paper. So I think that was like a big realization. And then yeah, this like the second the one here is like a web, like basically in our model similarity paper we released a website where we made like the paper and code which everyone gives obviously, but also like we made a pip package that makes it very easy to like measure model similarity for your own models. I think like some people have found it useful, and I've heard from people who use the package later for their own project. And we also released like an interactive tool, because like Hugging Face has like the Spaces thing, which basically allows you to host like some basic interactive scripts on Hugging Face. And again, this is very useful if someone wants to like, people are usually lazy in running code. So if they can get an interface where they can just plug in like type text and see what the results are, they are much more likely to do that. And then we also released all the model outputs and so on. And I think like this just increases, for example, this will really increase your citations, because maybe someone will cite you just because they used your pip package or they used your data. And the other thing is like keep posting about your paper on Twitter. Like we did this like answer matching evaluations paper, and these days my collaborator, like every time a new model comes out, he posts the result of that model on our eval. And one thing we noticed was that these posts about frontier models are like frontier model. We just run the same eval, and this gets way more traction on Twitter than our actual papers thread. And people just like to know about frontier models. So yesterday he posted about like the new GPT open source model and how it performed on our eval. And again, that got like more likes than like the pinned tweet about the research paper. So that really increases your visibility, because in the end, people care about how this affects like the end product that they're going to use. Yeah. Thank you, Paris, for inviting me again.
Yeah, this is looking forward to more interactions with you, Shashwat.
Yeah, same. Yeah.
Bye-bye.
Yeah, with that, like that's my spiel. I'm open to like questions. I'm going to stick around for like another like 15 minutes or so. So feel free to like ask whatever questions you have.
Hey Shashwat, can you hear me?
Yeah. Hi, Naveen. Yeah.
Yeah, Shashwat. So I think you quickly skimmed over the part about the bitter lesson. I'm just wondering, from your experience with the papers that you've published, have you had something similar? Can you talk about your experience with the bitter lesson?
Yeah, that's an interesting point. Okay, so in my papers, um, I feel like um, so a one thing is that I try to like incorporate the bitter lesson in every project, like from the start. So I try to like hedge my bets against this by just like not trying to engineer human intuitions a lot into like how I work with models. Uh, so if you can be careful about it, then the bitter lesson will be less bitter for your project down the line. But I guess like there are some things that do happen, right? So like one thing, for example, that I've observed is like you might be tempted to like write prompts for the model in a way that's like very mapped to like how you would think about a problem. Like you tell the model to like break down the problem in a very specific way that you think is needed to solve the problem for yourself. But in the end, like somehow it just doesn't work as well for the model. Like one thing people have even told me is that ask the model to write a prompt for itself. Like take your prompt, give it to the model, ask it to rephrase the prompt and see what it comes up with. Then you can see like what it really thought your prompt meant and just use that prompt and like use the prompt that the model came up with eventually rather than your own prompt, and somehow that works better. I don't know, like it's a research question whether this is actually true, but I've heard this from like some people. So this is like one example that I came across recently. The other thing is that like so I've seen like, for example, these days people care about agents, right? And a lot of people are like writing these multi-agent system papers or like tools where like you have like five agents doing different things. One agent comes up with a solution, another does something else with it, and you try to break it down in a very human way. I feel like all these papers will become irrelevant in like another 1 year or two because someone will train like an end-to-end multi-agent system using like end-to-end deep learning without like hand coding how the agent would break down the problem, and this will just like completely outperform their multi-agent system. So this is like another example of I think where people will feel the bitter lesson in the next 1 or 2 years. I don't know if this answers your question honestly.
Yeah, yeah, I think it does, Shashwat. Thank you so much.
Yeah, I also see some questions on chat. Yeah, so how to design better experiments in terms of minimizing impact of variables not being studied. Yeah, that's a good question. So obviously you can't study like every variable, and I think the question already assumes that, which is good. Um, I would say like, I mean, to some extent, you have to trust yourself that like if you think a certain variable is important, focus on that first. Like try to go from most important variable to like least important variable. List down all the variables you can think of, then like try to prioritize them and keep the rest for like your appendix or like later in the project if you think they are less important. Like it's just intuition at some point. At some point.
Hey, Shashwat, am I audible?
Yeah, you're audible. Yeah.
Yeah, thanks for the talk, first of all. Like I want to understand, and this is something like I primarily struggle with. Like, for example, let's say you have an idea or a problem you want to work on. Even on a conceptual level, you know what you want to like work on. But like, for example, like what I mainly struggle with, okay, how do you sort of go from that concept or a methodology to actually designing some concrete hypothesis and experiment ideas, and now basically experiment sort of like which can validate those hypotheses. So like do you generally like how do you approach it, and would you have any tips on like how can one approach it?
I think like yeah. So one thing is that this is a bit hard to answer because it like really depends um like on the specific like concept that you want to try and do. So I guess like the general principle is again like just like okay. So the first thing is like instead of thinking too much about it, try to come up with like the first experiment that you can run, and this can be like a very simple experiment that you think like if it like if it's a crucial assumption, it should like clearly show like ba- so always think about okay, if my experiment runs and like this is the outcome I get, what do I learn? Versus like if I get some another outcome, what do I learn? Like sometimes people just run experiments which no matter what the result was, they would still continue doing the same thing. So in that sense, it really didn't inform you going forward. So yeah, like um, just thinking about, okay, like if I run this experiment, these are the three things that could happen, and what would I do in each case? Like what would I learn in each case? That can be like useful in picking something. I guess that's again a very abstract answer, and it's harder to like talk about it without knowing your concrete problem. But like also like another thing is, yeah, I mean, just keep things as simple as possible. Don't try to like train a model as the first solution. Start with like basic prompting or like training free methods, and then like go further deeper into it.
Got it. Got it. Okay. Thank you.
Yeah.
So during the research phase, how many times do you have to change like your base hypothesis or like the direction that you're taking? What is the average amount of times that this has changed?
That's a good question. I think it also depends on how you define change. Like, so let's say you started with a problem. As long as you're working on the broad problem, uh, you can keep changing. Like, again, it's like a tree. Let's say you finalize on like some problem which is like somewhere in the tree. Now, obviously, you will keep changing on the sub problems and like the sub experiments to run and so on. That's fine. Maybe all of this is also like data towards like the data that you can put in the paper, that we tried this, it didn't work, we tried this, it didn't work. There maybe all baselines, right? So to that level, change is fine. If you're changing the fundamental problem a lot, that could be a problem, because then that means you're not making progress on anything, basically. So I would say, if you pick like a good problem which you think isn't like small enough that it will be solved within a month, then there should really not be a reason to change like direction completely. Or you could maybe realize down the line that like whatever you worked on was not a useful problem anyway, or it wasn't a problem at all, because like models already can solve it. In which case, then yeah, you have to change it. And if this was surprising, you can write a paper about it. If it was not surprising, then like yeah, you just have to like move on.
So Shashwat, just to expand on that, so obviously the problem remains the same, and if you have chosen your problem well enough, you can keep iterating on the hypothesis. But I'm guessing that, at the start of it, you probably had like a hypothesis or an idea that you firmly believed in was probably the root cause of why the problem exists in the first place. And then you try
Right.
it out, maybe you try out a few variations of that, and then eventually you might even come to a place where you realize that your initial hypothesis was wrong for so and so reason, right? So from there, where do you go from there, right? Do you go to something completely new, or do you abandon the problem? Or and how many times does this happen in the course of picking one problem and one project? How many times does something like this happen?
I would say it like the first thing is that it can happen quite often. I don't know how many times it happens, because that like really, really varies on like each project and how good your first hypothesis was, and like so on and so forth. So but I do think that it's actually good to change sometimes. If like, yeah, if your base hypothesis was wrong, it's actually good if you accept that you like fail fast, rather than like keep trying to going down the same rabbit hole and realizing 6 months later that you were wrong. So in general, like, it's good to fail, and in fact you should optimize for failing as fast as possible. At the same time, it's also important that you like you just have to build up the like engineering muscle in the way that like you can trust that if something failed, it was not because you implemented it wrongly. So the one thing that you need to test is that your implementation was fine. If something is failing just because your implementation doesn't work, then that's a problem. Like, so I mean, try to like do the best version of it as possible. But if in the end at some point you start feeling that this is not going to work, it's good to like change, because you will save time that way.